On May 28 this year, China's domestically produced mainline aircraft C919 officially began its commercial operations. However, whether C919 can truly carve out its own niche remains to be seen after it enters the market and withstands the competition from the industry giants, Boeing and Airbus. Nonetheless, the era of this three-way competition is already upon us. Many may be skeptical, thinking that C919 doesn't deserve to be mentioned in the same breath as the established classic, the Boeing 737. Don't worry, read on, and after going through my sharing today, I believe you will have some new perspectives. Let's begin. First, let me make one point clear. Objectively speaking, the extensive comparisons made from a technical perspective today are not meant to prove that Commercial Aircraft Corporation of China's, COMAC, C919 surpasses Boeing in terms of technological capability. The technological advantage of C919 lies more in a latecomer advantage built on the foundation of past experiences. If Boeing maintains a proactive attitude, continually upgrades its products, and accelerates the development of a completely new Boeing 797, this latecomer advantage of C919 wouldn't be so pronounced. However, precisely because Boeing has been too complacent, even a fledgling newcomer like C919 can comprehensively outperform its product. C919 need not be complacent, but Boeing should indeed reflect upon this. The Boeing 737 was developed in 1964 and commenced operations in 1968, and it has been in use ever since. Over half a century has passed, yet Boeing hasn't thought of developing a new platform to replace it. The only thing they've done is continuous fine-tuning, making structural adjustments or elongating the fuselage on the existing platform, doing a major overhaul roughly every 20 years. The Boeing 737 MAX, which began production in 2018, was the fourth major adjustment. Boeing has consistently offered us the vintage old aircraft, in its purest form. This kind of business approach is unimaginable in other industries. If an automotive company continued to use the old Santana model for decades, it would probably have been phased out of the market long ago. Yet, the Boeing 737 remains popular and is still the mainstay of major airlines. Does this old platform really possess such magical qualities that it doesn't require upgrades even after half a century of service? Certainly not. Aircraft manufacturing is a matter of technology, not art. There's no ageless concept. The main reason the Boeing 737 ages gracefully is primarily because there simply hasn't been another choice in the market. Of course, using an old product isn't without its merits. For instance, pilots don't need to learn new knowledge, making training relatively easy, and there's a plethora of parts available in the market, making maintenance easier. However, the most crucial advantage is cost-effectiveness, saving a significant amount in developing a new platform. The lack of innovation has resulted in the Boeing 737 being notably behind the freshly launched C919 in many aspects. Firstly, in terms of appearance, we can intuitively feel that the C919 has a more streamlined design compared to other aircraft. This is because the C919's cockpit utilizes 4 curved glass surfaces, while the Boeing 737 and A320 still use the outdated 6 flat glass panels. Curved glass not only provides a larger and better view but also reduces overall aerodynamic drag, making it more fuel efficient. It's important to note that for commercial airliners, fuel consumption has always been a significant cost. Therefore, many new technologies in aircraft are developed to save fuel. In this industry, fuel efficiency equates to competitiveness. Apart from using curved glass in the cockpit for fuel efficiency, C919 has another ace up its sleeve: the utilization of the globally leading supercritical wing design for its wings. The advantage of this design is that it generates fewer shock waves near the speed of sound, resulting in less resistance, making it not only more fuel efficient but also capable of flying faster. While this theory was initially proposed by Americans, the aging platform of the Boeing 737 prevented it from benefiting from this latest research achievement. However, in reality, this technology requires stringent requirements on the aerodynamic surface. To achieve the optimal results in practice, it requires sophisticated computing power and professional wind tunnel testing for repeated verification. This, however, is not an issue for China, as these infrastructures are its strengths, with wind tunnel facilities being unrivaled globally. Hence, C919 smoothly turned this research achievement from theory to reality. Additionally, the C919 extensively utilizes third-generation aluminum-lithium alloy materials. Compared to conventional aluminum alloys, this material can reduce the weight of aircraft components by 10% to 15% and increase stiffness by 15% to 20%. In simple terms, it's both more fuel-efficient and stronger. If the differences between the Boeing 737 and C919 are not easily noticeable from the appearance alone, from the perspective of pilots, these two aircraft are truly products from different eras. The Boeing 737 still uses a mechanical control stick reminiscent of old-style bombers, while the C919 has adopted an electronic control stick, requiring only finger movements for operation. Even an ordinary passenger can easily tell who is more advanced by comparing their cockpit displays. However, Boeing does have something to say about this issue. According to them, not upgrading the old mechanical control stick is primarily for the convenience of pilot familiarity. However, the electronic control stick is not a novelty introduced by C919. Airbus had already switched to electronic control sticks long ago, and there were no reports of pilot discomfort. Even if there were initial difficulties in adaptation, a period of training would solve it, making Boeing's choice purely a result of path dependence. In fact, the path dependence of the Boeing 737 goes beyond this. When it was first born in the 1960s, its wheels were exposed when retracted. This design was simple but increased flight resistance, severely affecting fuel efficiency. Now, over half a century later, it remains the same. We can see that the wheels of the latest model, 737 MAX, are still exposed. The reason for not covering them is due to lack of space. To increase space, structural changes would be needed, and they are not willing to make those changes. Furthermore, everyone knows that an additional, side business for aircraft is cargo transport, which involves loading aviation containers in the cargo hold. To maximize efficiency, both the A320 and C919 have optimized the cargo hold space according to the dimensions of aviation containers, allowing for 2 aviation containers to be placed side by side. However, due to its outdated design, the Boeing 737 has not been optimized according to the later standards and can only accommodate 1 container. This results in the side business income of the Boeing 737 being inferior to that of the other 2 competitors. From the above indicators, it is evident that the platform of the Boeing 737 is indeed outdated, not only delivering subpar performance but also incurring high operational costs. Of course, in terms of cost reduction, Boeing is not entirely complacent. They are exploring ways to cut costs. Besides upgrading the platform, what other methods can be employed to lower costs? There are ways indeed. Although aerodynamic layout can't be changed, you can replace the engines with more fuel-efficient ones. Aircraft engines have a characteristic: the larger the diameter, the more fuel-efficient. Hence, the size of new engines is always increasing. This is not a problem for A320 and C919, make them big if needed, there's plenty of space under the wings. However, the Boeing 737 faces a serious problem. The wing height is too low, and the landing gear is too short, resulting in very limited space to install engines under the wings. If the engines are slightly larger, they might scrape the ground and spark upon contact. Can't we raise the wings a bit? Unfortunately, it's not feasible. An aircraft is not a television, the entire design is a system engineering. Any change will affect the entire system, and the wings cannot be altered. What about extending the landing gear to add height to the aircraft? Still not possible. The retraction mechanism of the Boeing 737's landing gear involves the 2 wheels folding inward from both sides of the fuselage. In this mode, if the landing gear is extended too much, the two wheels would collide when retracting. Moreover, there's a large structural beam in the middle of the aircraft's belly, limiting the storage space for the landing gear. Boeing's engineers came up with an ultimate solution: flatten the engine compartment. Therefore, if we observe carefully, we will notice that the engines of the Boeing 737 are flatter compared to those of the A320. However, when it comes to the latest LEAP engines, a new issue arises. These engines are developed by the CFM International, a joint venture of General Electric from the United States and Safran Aircraft Engines from France. The LEAP engines represent the latest technology from General Electric, boasting outstanding fuel efficiency. They are currently the most fuel-efficient single-aisle commercial aircraft engines globally, and of course, they have the largest diameter. Among them, the LEAP 1A sold to Airbus and LEAP 1C sold to Comac have normal dimensions, both having a factory-set diameter of 78 inches. However, when designing the LEAP 1B for Boeing, they encountered an issue: this size was too large for the Boeing 737, making it difficult to fit under the wings. To ensure the product could be delivered to the customer, CFM International considerately modified the LEAP 1B, reducing the fan size, ultimately shrinking the engine diameter from 78 inches to 68 inches. This barely allowed it to fit, but the fuel efficiency was compromised. However, during the actual installation, they found that while this size could be squeezed in, the height from the ground was too low, not meeting aviation regulations and failing to mitigate the risk of inhaling ground debris. What to do? Boeing's engineers came up with the ultimate solution once again: slightly move the engine forward and raise it. As a result, the upper edge of the engine blocked the front of the wing. This genius maneuver increased the pitch torque of the aircraft and altered the overall aerodynamic layout. It's important to note that an aircraft's aerodynamic layout is highly sensitive. Protruding such a big lump suddenly in front of the wing, the aircraft immediately faces the question of whether it might fall. Boeing's engineers once again presented the ultimate solution: to correct the aerodynamic layout change's impact on flight status through modifying flight control software. Is this method reliable or not? Shortly after the 737 MAX went into mass production, it caused 2 consecutive crashes due to erroneous intervention by the flight control software. As a result, the global aviation industry was outraged and grounded all models of this 737 type. Boeing's response was to further upgrade the software. As for whether the software, after further upgrades, can completely avoid the risk of accidents, it's up to the brave consumers to try it. It's worth mentioning that earlier this year, India boldly placed an order for 190 737 MAX aircraft, demonstrating Indians' steadfast trust in Boeing. However, Indians' trust in Boeing is not surprising, as Boeing's flight control software was originally developed by them. Handling the outsourcing of the 737 MAX flight control software is HCL Technologies, an Indian company. In summary, C919's technological advantage over the Boeing 737 is quite evident, particularly in the area of passenger comfort. This concludes today's sharing, and we'll see you next time.